Okay, welcome back, guys. One of the final sections of the textbook, and here's where once again we put everything together. Now, we said the purpose of collating statistics, or one of the main reasons, is to hopefully make predictions, to use previously collected data, put it together, and to make a prediction about something. Now, we've got two types of predictions we can make. We can make a prediction within the data set, which we call interpolation, and we can make a prediction outside the data set, which we call extrapolation. I'll show you here. As you can see, our data set actually only goes from about, let's say this is about 13 to about 41, okay, in our x value. Okay, all our data values, all our points are between 13 and 41. So if we made a prediction at 20, okay, that would be pretty good because it's a prediction that's in the middle of our values. Okay, we could also make a prediction about 30. Okay, that would be good. Those two predictions, they're fine. But if I try and make a prediction at 60, that's way out of my data set. That's too far. Okay, these two would be okay. A prediction at 20 and 30, yep. But a prediction out here, it's not inside our data set. So these two I did first, 20 and 30, they would be interpolation, okay, and they would be okay. A prediction at 60 or a prediction at 0, they'd be outside my data set, so we'd say they're pretty unreliable. They're extrapolation, okay. We want to make a prediction inside our data set. So let's have a look. We've already made predictions using our line of best fit. This is just putting this over the top. Okay, so we've got our data, it's been graphed for us. Use the line of best fit to find the length of a spring. So this is comparing the association between how much mass we put on the spring and the length of the spring that it springs to, okay? The more mass, obviously, we put on the spring, the more it stretches out. Now we have one at 250 grams, so this is 210, 220, no it's not, it's going up in 25s, 225, 250, okay, so 250 is here, and we go up till we hit our line of best fit, and we go across, and we get to 40. Not too bad. And the next one we're going to do, I'll do it in a different color, is 30 millimeters, which is we're going from our y-axis, we go across, and we hit, and we go down, and that's 100, that's about 150. So this was 40 millimeters, and this was 150 grams. Okay, they're not too bad because if we can see, our data set goes from 100 to 500. Both those predictions are within my data set. Okay, not too bad. The next one, okay, all these, and we don't do this as much, all these lines of best fit, they have an equation. Okay, they have an equation that we can also use to make our prediction. So instead of using the scatter plot, we get an equation. So our equation tells us the length of the spring is 0.104 times the mass we put on it plus 14.8. Okay, now what we want to do is we want to put that together. Length equals 0.104 times the amount of mass we're putting on, 800 grams, plus 14.8. So we need to get a calculator up and we need to put that together. So that's just another way that we're doing it. Okay, we can use the equation. And we'll go into a bit more detail about this. So I'll have to get a calculator up. Sorry I didn't do this earlier. Got a few tabs up. I'll drag a calculator. So our equation was 0.104 times the mass. We're putting a mass of 800 grams on it. And then we're plussing 14.8. So that equation has been given to us. We can calculate that. I'll show you how to do that later. and we get a prediction of 98 millimeters. So we're being told, okay, as you'll notice, 800 isn't on our scale, so we can't do this prediction using the graph. We've got to use the equation. So when we put on 800 grams of weight, our spring will stretch to 98 millimeters. Okay. How reliable is this prediction? Well, we look. If our data set only goes to 500 and we've made a prediction at 800, this is unreliable because our prediction is outside the data set. Our data set only goes from 100 to 500. We're making a prediction at 800, so this is what we call extrapolation. Okay, if you were going to use that prediction, okay, you probably couldn't trust it, okay, because it's so far out of our data set. The other predictions we made, we can probably take them. They're probably pretty accurate because it's within our data set, within the range of our data set. Anything outside that, we kind of think, it's probably not that reliable. Now the next one, we're going to do it from scratch. So we're going to do what we did last week, calculate the coefficient of correlation coefficient, and we're going to make some predictions. Okay, and I'll show you how to get this equation to make the prediction. Okay, we want to get an Excel spreadsheet up, and we want to put the data in. Okay, so hopefully you can see that. We've got total height, your height and your waist height. So we have a look. We think your total height is used to predict your height of your waist. So we'll highlight it. First thing we'll do, and we'll get a scatter plot. I just need to move this. So we go insert, scatter plot. We've got a nice one there. Not too bad. Whoops. Okay. Next thing we want to do is we'll do our Pearson's to see how strong it is. Equals P-E-A-R-S-O-N, bracket. We highlight our first column, comma, our second column. Okay, that tells us how strong our association is, and it's positive because we've got a positive one. So it's above 0.75, so that tells us it's strong. So we put this back. If we go calculate the Pearson's correlation, it was 0.805. Then we want to make some predictions. Okay, prediction for someone who is 807 centimeters tall. So we go back down to here. We can do it a couple of ways. We'll go. We want to get our line of best fit. So we'll go to click on this, and we go to design. We go to quick layout. We've done this previously, and we'll do which one? This one will do. Okay. So we've got this. We can get rid of that. We don't need that there. And that spreads it out a bit more, makes our prediction a bit easier. So first one, we can go. So first I'll show you how to do it with this. We'll go, okay, first one we wanted to have a prediction of 170. So we go up. Okay, when our height, our total height, okay, our total height, it's this axis, is 170, we get 100. So we go back to here, and we've got 100 centimeters. And then we want to use this prediction to predict the waist height of a person who's 130 centimeters tall. So how reliable is this one? Well, if we go back to it, that's pretty reliable because 170 is within our data set. So this is reliable. But 130, that's not even on my scale. So now I've got a problem. Okay, this line of best fit doesn't extend, so I can't use my line anymore. So what do I have to do? If I go back, I click on the scatter plot, and if I go to design and quick layout, you'll notice if I go, it's just off the screen, I'll just show you, quick layout. If I go to this one, it gives me that, okay? It gives me an equation, which is y, or y is our y-axis, which is waist height, equals 0.9393 times x. X was our total height minus that. So just by going to quick layout, we can select, which one do we select? It was this one. It gives us the equation, okay? So because our line of best fit wasn't long enough to make that prediction, we're going to have to use the equation. So we go back and we'll just write this out. 0, oh, we might even just copy it. Control C. And this might not copy, might not be able to copy. Oh, here we go. Yeah, it copied. I'll just get to select. So there was our equation. We want to swap out y for total height, because that was our, no, y was our waist height, wasn't it? Because it's our y-axis, which is our RV, and x is my EV. Total height was our EV, waist height was our RV. So we go waist height equals 0.9393 times total height minus 60.386. So what are we subbing in? We're subbing in 130, because that's our total height. And we go back to our calculator. 0.939 times 130 minus 60.386, and we get 61.684 centimeters. So that's a prediction. If we've got a person who is 130 centimeters tall, their waist will be 61.684. Now that's not reliable because it's way outside our data set. This one, however, was pretty reliable, 100 centimeters. So that's all there, guys. There's a fair bit in that, but it's just putting a few things together. I've put all the instructions there for you, and I would like you to have a go at that. So we'll spend the whole double period on it. Take your time, but we want to start making predictions, putting it all together, getting the line of best fit, making the prediction, and the hardest thing it gets to is getting that equation. There's a few things in it. Just make sure, remember, y is our whatever our y-axis is, which is our RV. X is whatever the x-axis is, which is our EV. I can go through a few more examples of that if you want. Just let me know.